Hi everyone, welcome back. We continue on this list and today we are going to learn about calculate covariance matrix. You can also understand easily from the name. This function is just calculating the covariance matrix according to the input you are giving. Why we need this covariance matrix? Because in most of the cases this is gonna be the input of another functions. For example, mahalanobis function, which is also included in Opencv library. This mahalanobis function is gonna need this covariance matrix, or in another processes, in another matrix calculations, this covariance matrix is needed for many functions as input. So we need to calculate this covariance matrix. Then for purposes why we need covariance matrix, because this is important for data classification also. We don't need to know about the mathematical details clearly, but we need to know the purpose. This is used as input for most of the functions, and this is important for data classification in machine learning. So in mahalanobis function, maybe in the future videos we can we are gonna use this again, of course, and in there we can make an example about data classification and we can understand the importance of this function more clearly. Okay. Why this an overloaded function? They are just different than each other by the inputs they are taking. And here there are two output you can notice, because covariance matrix, okay, we need, but why mean is given as output? Because to calculate covariance matrix in the formula, in some way you need the mean. Mean is easy to calculate. We already learned about mean function, but they maybe when designing this function they thought, okay, we are already calculating mean because we need that mean in covariance matrix calculation, so why we don't give also this mean as output? That's all. And they are giving mean value as output also. Okay. And what else? The input are easy. Maybe we can use this second overloaded because more easy to understand. This is gonna be our input, and this is gonna be covariance output, and this is gonna be mean output. There are flex in here. We are gonna talk about this flex in the code part more clearly. For example, columns and rows totally will be better to talk in code part. And normal and scrambled, these are just different than each other by the formulas they are using. You can check detail maybe, but covariance normal is used in most of the cases. And for example, if you have mean value, you don't need this function to calculate mean again, so you can give the mean externally to this function. So maybe for time efficiency it's gonna be better. There are some flex, you can read detail also. Okay, let's switch to the code part. In here we need, this is the example from the previous video, and we need an input, of course, and this input is gonna be included some points in space. For example, this is 2 by 2, and maybe we can add one more, let's say 2 by 5 to, okay, let's say now this is including 3 rows. Just assume, by the way, this is representing the rows and this is representing the column. So since we need points, why we need points? Because in space we are talking about data, right, and data classification. So in some way we need to give the input as points. So these each elements, each row is representing the points. And if you have this input in many, it means you have many data in space, so you can classify these data. For simplicity to understand this function, we are only gonna use one data, which is input. And okay, this is representing the points we said, and now we need some output, which is first one is gonna be mean out, and the second one is gonna be covariance out. Okay, and we can call our function now, calculate covariance matrix, and which is in here. So we are gonna use the second overloaded one, and first we need to give our input, and then we need to see covariance matrix, which is gonna be our output, and mean out also we need to give. What else we need to give? Flex. So we are gonna use covariance normal, which is the most of the times used one, and also I want to combine this with rows. What this is gonna mean, we are gonna talk covariance rows. By this, let's open the explanation maybe. If the flag is specified, all the input vectors are stored as rows of the sample matrix. Mean should be a single row vector in this space. Okay, what this is meaning? We just give the input as rows, right? I mean, each point is represented by the row. So we are basically specifying this by this one. So another way it cannot understand easily. So we are giving our points in each row. Okay, we can also make an example with the columns, and then this is defaultly 64 float, but I think this is 32 float, so we can make it 5, which is, or y5, because 32 float is, the enumeration index is gonna be 5 if I'm not wrong. Let's have a look at, yeah, it's 5. And yeah, it's done. So we can see the input in the console. Then we can see also I want to make a gap, so it will easy to read. Okay, I want to see covariance output in the console, and also similarly I want to see mean output. Okay, now we can run the code and see the result. Yeah, basically this is our input, and this is the covariance output, covariance matrix. I don't know how it's calculated, via on the formula. You can check the formula, but it's calculated and given the result is like this. This is easy to understand, just 3, 1 and 2. Sum all these things is gonna be 6 divided by 3 and is equal to 2. Similarly, 8 plus 5, 13 divided by 3 is this result. Yeah. Basically, this function works like this. But what if we change this as columns, or yeah, if we change this as columns, so we combine like that. So it's little complicated, so it's not working well, because what this means now is checking the, for example, this is 3 by 2, but now it's checking, how to say, now it's reading like 2 by 3, maybe it's reading, but it's different, 3 by 2 matrix. So if we specify like this, now I believe it's gonna give the correct result. Yeah, now it's at least logical. Now it's just copying these 3, which is 10 divided by 3 is equal to this one, and 9 divided by 3 is 3. Now just by changing this from columns to rows, it means you need to also change the input matrix columns and rows, because you need to give as input as the combination, because the function also needs to be know your points inside the columns or inside the rows. So it's needed to be known. Yeah, this is working in that way. And yeah, basically this function is working like this. And as I said, this is gonna be the input in most of the cases of another functions. For example, mahalanobis, which is for most probably it's gonna be the next video. So in there we are gonna use these functions. Okay, just for this video it's done. See you in the next videos.